Now in this video, we're going to revise this topic of interactions. Now this is a P5 revision for interactions because and it doesn't cover the P6 topics on interactions like forces, like food web, food chains, mass impact and environment. But of course the P6 can also use this video because it helps to revise what you've learned in P4 on magnets. Now, study the interactions between and within systems enhances the understanding of the environment and man's role in it. Interactions simply means, right, it occurs within an organism, it can occur between organisms, it can occur between organisms and the environment, like us and the environment. The interaction of man with the environment drives the development of science and technology. At the same time, science and technology influences the way man interacts with the environment. By understanding the interaction between man and the environment, students can better appreciate the consequences of their actions and be responsible for their actions. That is a hope anyway, that we will all understand what we do impacts our environment in very big ways. So what will be tested? What can be tested? For example, you have to know that a magnet can exert a force, and this force is either a push or a pull. We call the pushing force repulsion or repelling something. We call the pulling force an attraction. And you should know that a magnet has two poles, and the two poles, one is a north-facing pole, one is a south-facing pole. And when you place the like poles, and like poles meaning, for example, north, north, south, south are like poles, they will repel. And south facing pole and unlike poles here will mean north facing south or south facing north. Okay, they're the same opposite thing, right? And this will attract, unlike poles will attract each other. And you know that a freely suspended magnet, which means you hang a magnet by a string or you put it on something that floats on water, when it comes to rest, it will point in a north-south direction. This is how you make your own compass. And you know that magnets can be made using magnetic materials. And there are two kinds of magnetic materials you must know, iron and steel. You can also make your own magnets through stroking it using one end of a magnet. You can make a magnet using batteries and wires, electromagnet. And there'll be a temporary magnet because once you switch it off, it will stop becoming a magnet. So how can we test you? We'll test you about items like, do you know what materials are non-magnetic materials, what materials are magnetic materials, and what are magnets? There's three categories here: magnets, non-magnetic materials, and magnetic materials. So these are things like wood, like plastic, and some metals are also non-magnetic, like aluminum, right? Like copper. These are things that are non-magnetic. Magnetic materials will only be these two. Right, I'm sure a tutor outside might have taught you some other magnetic materials. They will not be tested. You will not need to know them for purpose of exams. Right, it's good to know them as extra knowledge, but not needed for exams or tests. And you got to know how to make a magnet using a stroking method or the electrical method. Let's take a quick look now at one question. Which one will attract each other? This tests your knowledge on unlike poles will attract. Like poles, unlike poles, like poles, like poles. So answer here is 2. Or Ali grouped some objects according to their magnetic properties in the table below. It says a reminder to pause the video to try it on your own first before you attempt the before you listen to the explanation. So this is a table with two headings. This one describe object made of magnetic materials. This one describe objects made of non-magnetic materials. But Ali made some mistakes here. Okay, so which one are the mistakes? So magnetic materials, aluminum foil is not magnetic. Ali probably thought that all metals are magnetic material, and that is wrong. Okay, an iron nail is an object made of iron. Iron is a magnetic material. His socks are unlikely to be made of iron or steel, so this is also wrong. Objects made of non-magnetic material, wood is non-magnetic, plastic is non-magnetic, steel is also wrong. So what will be wrong? Aluminum foil, socks and steel bar. Aluminum foil, socks and steel bar. Okay, 3. When you say only, it means only these 3 items. Okay. Now, next question, electrical method. So electricity passes through the wire and coils around this. There are two ways to make an electromagnet stronger. One, we add more batteries. Another one is we have more coils around the nail. Right, you got to describe fully, yeah? More coils around. Otherwise, let's say more coils, I can say, oh, the coils are here, is it? Oh, so sorry, it's wrong. Once you're not clear, I'll assume you are giving some wrong information. So you got to be very, very clear and specific. How can he, and if you think that's not fair, that's not true. That's actually being very fair. Comparing to a child who writes, add more coils, to one who wrote, add more coils around the iron nails. Of course, credit must be given to the one who described it most clearly, right? If you give an answer that is incomplete or is not clear, how can your answer be worth the same marks or worth any marks compared to somebody who made the effort to remember everything correctly? So that is actually us being fair when we ask for accuracy and completeness in your answer. How can you make stronger? Size of the nail? Nonsense. Nonsense. Alright, this is correct. Decrease number of coils? Nonsense. Alright, answer is 3. Now when we did a quick revision on interactions for the lower block. Okay, now we can take a break, and then next one we're going to go on to will be revision on topic of cycles. Why are you still here? Go and take a break.